2.6. And we're going to be doing modeling with functions. This again is setting up word problems. Whenever you do these, my step's going to differ slightly from the book. First rule is always draw a picture if one isn't given. So second thing, need to figure out what you are solving. Which variable are you solving for? And give it a letter. This one is usually in the last sentence or two. Next one then is figure out what you are given and give them letters. Okay. Then you write all of this out as equations, which is basically just a translation. Then you need to set up an equation you could solve for the variable in step 2. That's the one you're after right here. And then the last thing is actually solve, which in this case you may not always necessarily need to do that. Sometimes they're just asking you for the equation. But solve and check for reasonableness. This is real important. Make sure that your answer actually makes sense. Okay, so let's work through an example here. You've got a farmer that has 2,400 feet of fencing. And he wants to build a fence to enclose a rectangular pasture next to a river with fairly straight sides. Thanks. Okay, he doesn't need fence along the river. Okay, so what are the dimensions of the fence that will enclose the largest possible area. And this is reasonable from his standpoint. Okay, so the first thing we need to do then is draw the picture. All right, so here's my river. And we want to build a fence, rectangular. So I know these two sides are going to be congruent. All right, what we're trying to find then, so here's step one. We've got our picture. And we don't need any fencing along here. Okay, so the next thing is to figure out what we're trying to find. So we need the area, we need a maximum area. Okay? That's what we're trying to find. Right? Actually, no. As you come back in, it says what are the dimensions. So what we need is length and width. Okay, so let's call this W. That means this is going to be L, and this is going to be L. And that's what we're after, are L and W. Okay, so we've got that. So now let's come in and do step 3. We just figure out what else we are given. Okay, well, we've got this up here, 2,400 feet of fencing. That's how much fencing he has, and that is our perimeter. Okay, so we now have area, length, width, and perimeter. And length and width are what we're after. That's our final answer. Okay, so with that, let's go on to step 4 and write out some equations. Perimeter. Okay, now you guys are used to perimeters being 2L plus 2W. That's all the way around. Remember, we do not need to put along the river. So the perimeter is going to be 2L, but I'm only going to need 1W. So there's part of it. Area is length times width. So there's our equations. And you thought that was going to be the hard part. All right, so we've got all of this. Now we need to come back in and set up an equation we can solve for this thing. Okay? So what I'm going to do, this thing has both L and W in it, but I notice I do not have any of these 3 numbers. I have no values for anything. However, we know we're dealing with the maximum area, and we know how to find maximum and minimum of parabolas, so we suspect we're going to get this somehow or other into a quadratic, which will make sense with these things. But in order to do that, I'm going to need to get rid of one of these 2, and this is where this comes in. So we come back in. Now I've got a number here, okay? So I'm going to solve for W since I only have one of them. So W is going to equal to 2,400 minus 2W. Okay. Well, so far, we're in there. We're coming back into this thing. So now I'm going to come back in and plug this in for W into my area. So area max is going to equal to L times, and now I'm going to plug in for W, 2400 minus 2L, which is 2400 minus 2L squared. And there's our quadratic right there. Okay? And that's what we're after. So in order to do that, we need to find the vertex of this parabola. Okay, well that's not so bad. But in order to do that, we need to get this thing into, excuse me, we need to get this into vertex form, and in order to do that, we're going to have to complete the square. So my area is going to equal to negative 2L squared plus 2400. All right. I don't have a 1 in front of there, so I'm going to have to factor out my negative 2. That's going to leave me with L squared minus 1200 L. Yeah, when I distributed that in, I forgot to put my L there. Okay. So now we complete our square. Half of this is going to be negative 600. We'll have a negative 2 L squared minus 1200 L plus 600 squared. You ask me, okay, how come you don't have a negative in there? I do, but you remember when you square negative, you get a positive. So I've added this times this in, so I need to add 2 times 600 squared. And when you do that, I'm going to have a negative 2, and I'm going to have a L minus 600 squared plus, and this comes out to be 720,000. And if you remember, that should be our L. So the L that you give it to me is going to be 600 feet. My area then should be 720,000 square feet. Okay, it gives me L. We need to plug back in into area. So it would be this divided by this, and that gives me 1,200 feet. All right, and there's an answer. Now to check this for reasonableness, what I did on this was I went in and I just started making some numbers around these. So I did L, W, and area. So I started off with 400, and that gives me 1,600 for W. Need to make sure that 2 times this plus this, 2 times 400 plus that gives me 2,400. That's my parameter. When I multiply them together, I end up with 640,000. So then I bumped it up to 500, and this went to 1,400. And when I calculated that out, I got 700,000. Okay, notice I've increased here, so that's good. So now we go to our 600. All right, that's 1,200, and that gets me 720,000. Now you'll notice this is what we're looking at, but I've also increased a bit. So what should happen then, if this is indeed my maximum, when I go up, let's go to 700. And that should give me 1,000. When I plug it in, I end up with 700,000. And I've got a decrease. That makes me feel really good about this being a maximum. Okay, let's take a look at another example here. So basically our dimensions ultimately are going to be 600 by 1,200. You tell him that you build that is the size fence he has, which will give me the maximum area enclosed. Okay, let's take a look at another example. I've got two ships. It's left port at the same time. One went south at 15 miles per hour, and one went east at 20 miles per hour. Find the function that models distance b as a function of time. T. Okay, so the first thing we're going to do is draw a picture. Here's my port. So I've got one going south at 15 miles per hour. And I've got another one that's going east at 20 miles per hour. And if this is where they're located in a particular time, the distance is the straight line between them. So that's capital D. That's a right triangle. That would give away exactly what you're doing with this. But you notice, in step 2, what we're after is I want D as a function of T equals something. We're not after a number. It just says define the function. All right, so we've got everything here we need, except that these are not distances. So I'm going to introduce D1 and D2. Distance 1 is the speed that that ship is traveling, which is 20 miles per hour. Times the time it takes it. D2 is going to be the speed that ship is traveling, 15 times T. So my distance squared is going to be equal to D1 squared plus D2 squared. Then I plug in for these ones, so D squared is going to equal to 20T squared plus 15T squared, which is 400 T squared plus 225 T squared, which is 625 T squared, and that's D squared. So I'm going to take the square root of that, and because I'm after distance, I'm only interested in that. Square root of 625 is 25 T, and there is your formula for distance. And we come back in and check for reasonableness. So I'm dealing with 15 and 20. The idea that the distance is going to work as 25T, considering that is the hypothesis, certainly seems more than reasonable. Also, if you go back to geometry, you should remember that this is a 3, 4, 5 right triangle.